As a programmer, sometimes we follow things blindly. For example, let's talk about coding conventions and some of the tips and tricks and tools shared by the people we follow. Even some of the things which are being used in practice for a very long time, for example, design patterns. We follow these things without questioning them. I'm not saying that these things are incorrect or wrong or not suitable. What I'm trying to say is that if you do not question them, there is no way you can come up with new set of practices. Until unless you question, you will not be able to get the rationale behind it. And if you do not get the rationale behind it, there is no way you can understand it or extend it or recreate something new. But I, as a programmer, in my whole programming life, I tried to question a lot of things. And to a large extent, I can attribute all my successes as well as failures to this particular trait or characteristics. And one of such thing which I questioned was data hiding in C++ programming language. If you are using C++ in your organization, you must be having some kind of coding convention or best practices related to data hiding, which means you have to put some of the members of your class with private or protected access specifiers. And this is something never made any sense to me, because if somebody is a C++ programmer, these things aren't going to prevent anything. It may give you a compiler error and it may help maybe new or novice programmers to do something about it. But as an experienced programmer, you understand after some point of time that it doesn't make sense to do all those things, to have a variable, then have setter and getter functions, because of the things you can do in C++. Maybe in C Sharp and Java you can't do those things, so you'll have to use that and they are more useful there. Now, I know what you might be thinking, this doesn't make sense. Let me show you a piece of code and let me tell you how and why it will make sense. So you can see a C++ code on your screen right now. So here I have a class, it has a private val, and I am creating the instance of a class as AC. So everybody knows that what will happen if I say ac.val equal to 100. I will get a compiler error, okay, because it will say that this val member is inaccessible because of this private, and if you make it public it will work, right? So let me make it private. So this is what data hiding talks about. It says that if you want to set something, create a public and then have a setter function, you know, and then have a getter function. Sorry, right? Here you can say val equal to x, something like this. And if you are not doing this, you'll get a comment in your code review for sure. Okay. But what I'm trying to say is that it doesn't make any sense, because I can access this val even if it's private. So let me talk about this AC. I know AC is a class object. Okay. And the first member of class is variable called val, which means the first 4 or first 8 bytes will belong to val. So I can create a pointer and say that something like this, okay, and here I can say star of p is equal to 100. Now I cannot print this, right, because if I try to print this saying that ac dot val, I'll get into same problem. So let me put a breakpoint over here so that I can show you the value of the variable. So this is my class object and val is 100. So even if my this val member is private, I can directly access that. Okay. And tomorrow, if let's say I have something called val1, okay, and I can say that star of p plus 1 equal to 200. And if I show my debugger over here, you can see that first is 100, second is 200. I can access all those variables within C++. And this private access specifier has no way to stop me from doing that. And this is true even for the derived classes. You can derive a class called B class from A class, and then you can access all the elements, whether it is private or protected. So with the pointer manipulation, you will be able to handle it, and as long as there are pointers in C++, these access specifiers has no value. Okay, you can access those variables. Now many of you will say that if I have a setter function, I'll be able to check the incoming value so that I know I am assigning only the right values to the variable. All those things are fine, but how many times there was an error, there was a defect, there was some problem because of somebody setting some wrong value in a particular variable. Okay, most of the time the root cause is something different, and it's my personal opinion and as well as perception that many a times we are forcing developers to focus on the wrong things than the right things. I'm not saying that the way I have showed it to you is the correct way of doing it. My intention was to show that there are other ways of accessing the variables, but I don't think that the keywords called public or protected has prevented any bug or something like that. Okay, again, disclaimer, it's my own personal opinion. Okay, so this is what I wanted to share with all of you in this particular video. I do hope that this information was useful to you, whether or not you are going to make use of it. Thank you all. Thanks for watching. We will meet again. Until the next time we meet, good day, goodbye. You take care.